Okay, Bismillahirrahmanirrahim. So, in this chapter, I'm going to explain about chapter 5, which is induction motor. Okay, so what is electrical machine? Okay, motor and machine is different meaning. Okay, machine is in general. Okay, motor is part of machine. Okay, so electrical machine is a device which convert electrical energy into mechanical energy. So from electrical to mechanical, or from mechanical to electrical. So motor electrical energy into mechanical energy. So meaning that it produce electrical and then it convert into mechanical energy. In term of shaft, and connected to load. Okay, so and then for generator, from mechanical into electrical energy. Okay, so usually this one is at generator side lah, and then this one is at load side. Okay, motor we use as a load, and then generator as a generator. Okay, so for in this chapter is induction motor, so we focus more on induction motor. Okay, so what is definition of induction? Okay, the process by which an electromotive force ataupun EMF is produced in a circuit by varying the magnetic field linked with the circuit. So yang ni the process is similar with transformer, but for this one is in term of rotation. Okay, transformer dia tak rotate, dia adalah static. We call static motor ataupun static machine. But for this one, it's a rotation. It's on rotation. Okay, induction machine usually used as a induction motor. Okay, machine we know that ada motor and generator, but for induction we usually use as a induction motor. Okay, rarely used as a generator because of its low efficiency. Okay, because of when we use as a generator, the efficiency is low. Okay, this one you can read by yourself. Okay, so for in term of construction, okay, divided into stator and rotor. Okay, stator is the static part ataupun stationary, and then rotor is rotation part. Okay, so this is how the induction process happen. Okay, from the stator, electromagnet is formed at the stator, and rotor when AC supply is connected. Okay, interaction between the magnetic field of electromagnets generates twisting force of torque. As a result, the motor rotates in the direction of the resultant torque. Okay, so it become induction motor lah. Okay, so this is in term of stator construction. So remember, stator adalah static part. So on stator dia ada coils. Okay, coils are placed in the slot to form a 3 or single phase winding. Okay, and then for rotor, okay, rotor either wound rotor ataupun squirrel cage rotor. Okay, the conductor would look like one of the exercise wheels that squirrel or hamster runs on. Okay, kenapa dia panggil squirrel cage? Okay, because of okay, you can baca tu lah. Okay, so this is wound rotor, another types of rotor. Okay, so this is how magnetic field produced. Okay, three-phase stator winding is connected to a three-phase voltage supply. So remember, dalam motor kita ada stator winding dekat stator. Okay, dekat motor kita ada two part, stator and rotor. Okay, and then dekat stator kita ada winding. Okay, when we connect three-phase voltage supply on the stator winding, okay, three-phase current will flow in the winding. Okay, and then three-phase flux will be induced in the rotor. So that's why we call induced ataupun induction motor. Okay, flux will rotate at the speed called synchronized speed. So NS ni adalah speed of flux. Okay, NS adalah speed of flux ataupun synchronized speed. Okay, the flux is called as a rotating magnetic field. So this is the formula for synchronized speed, and S equals to 120 F divided by P. So F is frequency in hertz, and then P is number of poles. Okay, Number of poles. Poles tu adalah kutub Okay, and then this is the other relationship between sleep and NS. Okay, sleep defined as a difference between synchronized speed, okay, which is magnetic field speed, and rotor speed. Okay, the difference. So dekat motor dia ada two type of speed. Satu NS, satu NR. So NS ni adalah synchronized speed, kita punya speed of flux. And then rotor ni adalah NR adalah rotor speed. So remember, we have stator and rotor part. So this is the rotor speed. Okay, NS minus NR. So for induction motor, NR is always less than NS. Okay, always less than NS. Okay, and then slip adalah the difference the difference between NS dengan NR. So by equation S equals to NS minus NR divided by NS. So S ni adalah slip slip. Okay, and then this is the formula for rotor speed. So actually you can rearrange this formula, and then you can get the rotor speed NR. So NR equals to NS 1 minus S. So the unit is RPM. For NS also the unit is RPM, rotation per minute. Okay, so this is the circuit that we going to use. Okay, if you can still remember on transformer, okay, so actually the circuit looks like transformer. Okay, dia ada this branch and then dia ada this branch. Okay, so but this is the stator because of motor dia ada stator and rotor part. So R1 and JS1 represent stator. Okay, stator impedance, and then JX2 and R2 over S represent rotor impedance. Okay, and then for RC RC adalah core resistance. Okay, adalah core resistance. Okay, so this is the equation for stator current. Okay, kita dah masuk on analysis on induction motor. Okay, we start with stator current. Okay, stator current. Okay, so this is V phase, I phase. Okay, I phase is equal to I out. This is I out. We call I out, which is flow through RC and GSM. Okay, plus with I2. Okay, I2 ni this one lah. See lagi, this is I1, this is I2. Okay, per phase. Okay, that flow through this one. Okay, so I phase is I out plus I2. Okay, so how to determine I out? Okay, because of RC and GSM is in parallel, so V divided by this impedance in parallel, so we get I out. And then for I2, okay, V which is parallel on this side, okay, divide by R1 plus JX1 plus R2 over S plus JX2. Okay, so we get I2 phase. This is I2 per phase. Okay, so then you can determine lah I single phase. Okay, so next one is power flow diagram. So power flow diagram, okay, we start with input power P in, and then of course we have losses. Okay, because of firstly stator iron losses. Okay, we call SIL, and then we have stator copper losses. Okay, and then we have rotor input power. Okay, so ini adalah on stator part, and then this one is on rotor part, and also kita punya output power lah. Okay, so this is rotor input power. Okay, and then for this side is rotor copper loss RCL, and then this is mechanical developed power ataupun developed mechanical power, which is PM, and then PMU. This is PMU adalah okay, mechanical losses. Okay, this is stator part, rotor part, mechanical part, and then output power. Okay, so this is the the power equation. Okay, actually for stator copper loss and rotor copper loss is because of the RS and RR ataupun R1 and R2. Okay, so if you can refer this circuit, okay, this one R1. Okay, the general formula for power is P equals to I squared R. Okay, we know that P is equals to I squared R. Okay, so to determine firstly adalah power stator copper loss, that because of RS ataupun R1. Okay, the current flow through R1 is I2. Ini adalah I2. Okay, and then the multiply by 3 because of the 3 phase motor lah. Okay, multiply by 3. So ataupun you can write 3 I2 squared multiply by R1 ataupun RS. R1 sama juga dengan RS. Okay, parameter yang sama. One referred to stator as pun referred to stator. Okay. Okay, same goes for rotor copper loss. Okay, RCL. Okay, RCL is R prime R. Okay, so the current that flow through R prime R adalah I2, and then multiply by 3 is because of 3 phase motor. So 3I2 squared multiply by R prime R. So you can get rotor copper loss. And then for rotor input power RIP, okay, so because of R prime R is R2 over S ataupun RR over S is air gap resistance. Okay, yang ni so yang ni dia represent air gap resistance. So that's why lah, to determine rotor input power, so we use this equation. Okay, the current that flow this one through R prime R over S is I2. Okay, multiply by 3. And then for mechanical power, okay, so yang ni actually dia ada dia punya derivation, but in our case we just apply the formula. Okay, so as you can notice here, yang ni semua adalah 3I2 squared. Okay, 3I2 squared. Okay, and then multiply by inilah based on the resistor. So and then we can get the power. Okay, so next we can derive the power equation in term of slip and power. Slip adalah S. Okay, power adalah the other power. For example, we have rotor input power. So the original equation is this one, I2 squared R prime R over S. But we can relate with PM. So RIP equals to PM 1 minus S or RCL over S. Okay, so for example, RIP is 3I2 squared R prime R over S. Okay, and then PM, PM is equals to I2 squared R prime R, 1 minus S over S. Okay, so if you can compare here, so this one is equals to this one. Okay, so if we multiply RIP, dia ataupun this include S, this one RIP ni is equals to this one. Okay, so yang ni adalah RIP. So PM is equals to RIP multiply by 1 minus S. Okay, so in term of RIP, okay, so ini adalah RIP, ini adalah RIP. Okay, sebab R prime R over S multiply by this one adalah RIP, and then RIP is equals to PM over 1 minus S. Okay, and then for RCL, RCL is equals to I2 squared multiplied by R prime R. Okay, so if we compare with RIP, okay, so this one is RCL. Okay, RIP is equals to I2 squared R prime R over S. Okay, so this one is RCL. So we can write RIP equals to RCL over S. Okay, RCL over S, ataupun we can write RCL in terms of RCL. Okay, so this is RCL. Okay, RCL is 3I2 squared R prime R, and then if we compare with RIP, so this is RCL over S. So RIP is equals to RCL over S. So in terms of RCL, okay, RCL is equals to S multiplied by RIP. Okay, so this is important because of sometimes it just give one, satu je power dia bagi. For example PM. So from PM you can determine RIP, and then from RIP you can determine RCL. So you have to know the relationship between RCL, RIP and PM. Okay. Okay, so for the complete equation you can refer on the slide. Okay, RIP, RCL and PM. So RIP you can write in terms of PM, and then RCL, and then RCL you can write in terms of RIP. Okay, same goes for this one. PM equals to, okay, you can write in terms of RCL and then RIP. Okay, so actually you can hafal yang ni je satu. Okay, RIP. Okay, sebab ni dia dah ada tiga. Dah ada tiga RIP, PM dan RCL. Okay, so next is in term of input power. So for motor, okay, because of motor is come from supply. So supply actually is fixed, okay, because of from our ni lah utilities. Okay, in Malaysia is from TNB. So actually we can know the value for supply. Okay, so P input power is equals to square root of 3 VLIL cos theta. So remember this is in term of line parameter. So that's why lah multiply by square root of 3. And then theta, of course, the difference between, okay, voltage, angle for voltage minus angle for current. But phase, V phase, theta V phase minus theta I phase. And then also equals to 3 V phase I phase cos theta. So this one is in term of phase parameter. Okay, and then is equal juga P out plus P losses. Okay, we can determine P in by P out plus P losses. Okay, ketiga-tiga equation ni adalah sama, which is to determine P in. And then for output power, okay, P out is equals to P in minus P losses. Okay, P in, so this is P in minus all the losses, you can get the output power. So P out minus this one minus this one minus this one minus this one, you can get output power. Or P out equals to Pn minus P mu. So if you already know the PM, so PM minus this one, you can get this one. Okay, sama juga for this one. Kalau you ada information about RIP, you can RIP minus RCL, you can get PM. Okay, ataupun you want to determine RIP, input power minus the losses, you can get RIP, rotor input power. Okay, to determine PM, RIP minus RCL dapat PM. To determine output power, PM minus P mu dapatlah output power. Okay. Okay, so yang ni adalah losses. RIP, PM adalah useful power, which is power that we use, okay, for the motor lah. Okay, starting from this one and this one. Okay, so next one is efficiency. Okay, the general equation, of course, P out over P in multiplied by 100%. Okay, P out, okay, we can get from the above equation. Okay, this one lah, yang saya tunjuk tadi, this one P out, and then P in based on P out plus P losses. Okay, multiply by 100%. Okay, so yang ni dia tak fix. Sometimes you get from P-in, set 3 VLAN island cos theta ataupun 3 VP I phase, V phase I phase cos theta. It depends on question. And then next one is the equation for torque. Okay, 60P over 2 pi n. Okay, n ni adalah rotor speed, bukan ns. Okay, rotor speed. Okay, P ni adalah power. Okay, and then bergantung sama ada dia nak output power, mechanical torque. Okay, kalau yang ini dia nak mechanical torque, P ni adalah PM, P mechanical. Okay, N still lagi rotor speed. And then kalau dia nak output torque, ni adalah output power, yang ni adalah NR. Okay, bergantung. Okay, and then this is maximum torque. Okay, so you have to remember this equation, and then starting torque pun you have to remember this equation. So 3 Vs V phase, secondary voltage per phase squared divided by 2 omega s. Ini adalah synchronous speed in radian per second. Okay, and then multiply by di parameter lah. Okay, so x ni adalah x1 plus x2 ataupun xr plus xs. Okay, you can refer di circuit. Okay, right, that's all for theory on induction motor.